There's a very specific, I don't want to say dangerous trap that every programmer falls into.
Oh, I think I know where you're going with this.
And not just programmers, really. Any creative person, they hit this point. It's usually like 2 in the morning.
Right.
The work is, well, it's ugly, it's messy, but it works. The code compiles, the tests all pass, the project is, technically done.
Yes, the if it ain't broke, don't fix it phase.
Yeah.
That is a very seductive place to be.
Exactly. And pure logic. I mean, just survival says, go to bed, leave it alone.
Don't touch it.
But then there's that little voice in the back of your head, the voice that says, yeah, the plumbing works, but the pipes are crooked, and that joint over there looks a little rusty.
The perfectionist, or as we're going to call them today, the software plumber.
Right. And that is exactly where we're starting this deep dive. We're looking at a really fascinating piece of technical thinking from a blog called qianmeng.org. The author, Ang, he describes himself as an old software plumber, which I just think that's a fantastic title.
It is. It really implies that coding isn't just about, high-level abstract math. It's about the grit, the fittings, the actual flow, making sure nothing leaks.
And today we're zooming way in on his notes on Haskell programming, specifically part 58. It's a story about a tiny code change. I mean, literally just a few characters that opens up this huge conversation.
A conversation about how computers actually run our code.
Right, exactly, and how we communicate with other people through our code. And honestly, a pretty sharp lesson on why we can't fully trust AI to teach us these things.
It's a classic case of the why being so much more interesting than the what.
So let's set the scene. Ang is working on a project called X2 ebook. For those of us not converting libraries of XML files, what is he actually trying to do here?
So X2 ebook is pretty much what it sounds like, a tool for converting XML into ebooks. And Ang is doing what any good plumber does. He's inspecting the pipes. He's reviewing the code base, specifically the main function, which is the entry point for the entire program. But he's not doing it alone. He's tasked an AI assistant to review it with him.
Which is the modern version of bringing an apprentice to the job site. You just hand them a flashlight and say, tell me what looks wrong.
Exactly. And the AI points right at the main function, the front door of the whole application, and says, you should probably change the type signature here.
Now, before we get into the change, we need to understand the before state. Because as we said, the code was working, right?
It was working perfectly. The original type signature for that main function was main.io args.
IO args. Okay, for listeners who might not be fluent in Haskell, let's unpack that. 2 parts. IO and args. Let's start with IO.
Right. So in Haskell, IO stands for, input-output. Haskell is a pure functional language.
Right. So pure means no side effects. Like it can't just go and delete a file whenever it wants.
Exactly. A function should, by default, just calculate stuff.
Yeah.
Take an input, give an output. That's it. It shouldn't be changing the world around it.
But that sounds kind of useless. A program has to do something.
It does. And that's where IO comes in. It's like
Right.
a safety wrapper. It tells the compiler, hey, inside this box, we're going to do some dirty work. We're going to touch the file system.
Okay, so that's the IO part. What about the args part?
That's the return type. So IO args, it basically translates to, this is a computation. It interacts with the outside world, does some work, and then when it's all done, it hands back a value of type args.
And args in this case was just the command line arguments, the instructions the user typed in.
Exactly. The stuff that was parsed right at the start.
So logically, that makes sense to me. The program starts, it parses the arguments, it does its work with those arguments, and then it returns the arguments it worked on. It feels like a complete loop.
It follows a certain logical flow, yes.
Yeah.
You start with arguments, you end with arguments.
Yeah.
It feels symmetric.
But the AI looks at this symmetric working code and just says, nope. It suggests changing it to main.io.
Iowa.
And just so we're clear, that's not a typo, is it? That's actual syntax.
Oh, yeah. In Haskell, that empty pair of parentheses is called unit. It's an empty tuple. It basically means nothing.
The void.
It contains zero information. It's the void.
So the AI is saying, don't return the data, return nothing.
Precisely. And the code change reflected that. In the old version, the last line was return result, where result was the arguments. In the new one, it's just return.
Okay, this is where I get stuck, and I think where Ang got stuck too. If I return args, I'm technically preserving information. If I return, I am actively destroying information.
Right.
Usually in engineering, preserving information is better. So Why is nothing better than something?
That is the friction point.
Yeah.
And Aang didn't just blindly accept it. He's a plumber, remember. If someone tells him to cap a pipe, he wants to know why.
He wants to see the building codes.
Exactly.
Yeah.
He wanted the law. So he went looking for the source of truth. And in the world of Haskell, that is the Haskell 2010 language report,
The sacred texts.
the literal law of the language. He pulls up section 5, which covers the module system, and he finds the answer. But it's a weird answer.
Okay, walk us through what the report actually says, because I'm guessing it's not plain English.
It's actually this beautiful bit of technical legalese. The report says, the value of the program is the value of the identifier main in module main, which must be a computation of type IO.
Hold on. I-O tau. What's tau?
Left, it's the Greek letter tau. In type theory, like in this report, it's just a placeholder, a variable. It means any type. It's a wildcard.
Okay, so it could be an integer, a string, or args.
Or args. Exactly. So IO args fits the description. Args is a type, so IO args is a valid IO tau.
And I-O, the unit type, is also a valid I-O tau.
Correct. Both are legally compliant with the standard.
So wait a minute. The AI was technically wrong to say it needed to change. If both are legal, then why does it matter? The AI made it sound like the original code was bad.
Because of the very next sentence in the report. This is the aha moment that Aang found. The report continues. When the program is executed, the computation main is performed, and its result of type is discarded.
Discarded.
Discarded. Thrown away into the digital incinerator.
So all that time Aang spent making sure the args were correctly passed back to the end of the function.
Oh.
All that logic. The runtime environment was just taking that args object and dropping it on the floor.
It's worse than dropping it. It completely ignores it. See, when an operating system runs a program, it has no idea what a Haskell data type is.
Right.
Linux or Windows doesn't care about your internal arg structure. They care about an exit code like 0 for success or 1 for failure to tell the shell what happened. But the actual Haskell value returned by main, it just evaporates.
Wow. It's like writing a heartfelt letter to the IRS on the back of your tax return.
Yeah.
They're going to process the numbers, but nobody is ever reading that letter. It's going straight to the shredder.
That is a painfully accurate analogy. You are performing this calculation, wrapping it in a nice package, and handing it to a system that basically says, I don't have hands to hold this.
Okay, so if the result gets trashed, either way, we're back to my original problem. If IO args gets trashed and IO gets trashed, why is IO considered better? Why did the AI insist? Is it just aesthetics?
This is where we move from computer science to software engineering. Computer science is about what is computable.
Okay.
Software engineering is about what is communicable.
Communicable to who? The computer obviously doesn't care.
To other humans, to your future self, to the next poor developer who has to maintain this code 3 years from now.
Go on.
Okay, imagine you're a new developer looking at this code. You see main.io args. You stop. Your brain starts spinning. You think, wait, why are we returning args? Is this value being used by some wrapper script? Is there a test harness that intercepts this? Did I miss a dependency?
You're creating cognitive load. You're making me solve a mystery that doesn't actually exist.
Exactly. It's a red herring. You are signaling that this value matters when in reality it doesn't. You're lying to the next person who reads the code.
Whereas IO
is the universal symbol for the end. It explicitly tells the reader, the buck stops here. No data leaves this room. The side effects happened, the files are written, and we are done.
It's about honesty.
It's about semantic clarity. Aang puts it really well. He says, using IO is the proper convention. It's about clean pipes. You don't leave a pipe open if nothing is supposed to flow out of it. You cap it.
IO is the cap. I love that. It's not about whether the water flows. It's about whether the next plumber knows the water isn't supposed to flow.
Precisely. And in a team, or even just coming back to your own code 6 months later, those signals, they're everything.
But there's a twist in this story that I found, well, honestly, a bit concerning. We've been giving the AI a lot of credit for suggesting this fix.
Right, for spotting the convention.
But Aang's actual interaction with the AI, it wasn't exactly smooth sailing, was it?
No, and this is, I think, a really crucial takeaway from his post. The AI correctly identified the pattern. It said, change this to IO.
Okay.
But when Aang asked the obvious next question, why, the AI started hallucinating.
It couldn't cite the law.
It struggled, big time. Aang mentions he had to prompt it several times before it actually cited the Haskell 2010 language report. It gave him vague answers or just wrong reasons before it finally landed on the truth.
This is the black box problem, isn't it? The AI has seen millions of lines of Haskell on GitHub. It knows that main I/O is in, what, 99% of them?
So it just blindly recommends the pattern.
It's pattern matching, not reasoning.
Exactly. It's like a parrot that knows to say Polly wants a cracker, but has no concept of hunger or baked goods. It knows I/O goes with main, but it doesn't really understand why the concept of discarded values until you force it to look it up.
And Aang has a pretty sharp warning about this. He calls them glorified search engines.
Which is harsh,
Yeah.
but in this context, it's fair. He writes that they require constant verification and judgment from our end. The AI is a tool. It's not an oracle.
Just think about the irony there. If Aang hadn't been this old software plumber, if he'd just been a junior developer, he might have just made the change because the AI said so.
He would have improved the code, sure, but he wouldn't have improved his own understanding.
He would have fixed the pipe without understanding the physics of water pressure.
Yes. That's a scary thought.
Yeah.
A whole generation of programmers who have correct code but absolutely no idea why it works.
That's cargo cult programming on steroids. We do the ritual because the Oracle told us to, not because we understand the theology.
So the lesson is, use the AI to spot the anomaly. Let it find the rusty pipe, but use your own brain and the documentation to verify the reason before you start wrenching on it.
Trust, but verify. And maybe verify twice if it involves type theory.
Good advice.
Now, speaking of Aang's brain, I spent some time poking around his blog, kianmeng.org, while we were prepping this. This guy is not just a coder.
Oh, it's an eclectic mix, isn't it?
We're talking notes on Haskell, obviously, but right next to it. Notes on fish keeping, notes on gardening, notes on meditation.
And notes on home improvement, which fits the plumber theme perfectly.
And he's been doing this for years. This Haskell post is part 58.
It paints a picture of a specific type of mind, I think. The tinkerer, the chronicler.
You see this in engineering fields a lot, right? The person who doesn't just have a fish tank, they track the pH balance in a spreadsheet.
Yes, they don't just water the plants, they document the soil composition. It suggests that the mindset he applied to this tiny code refactor digging, for the truth, verifying everything, cleaning up the pipes, is the same mindset he uses for everything.
It's a systemic view of the world. Whether it's a Haskell runtime or a freshwater aquarium, it's a system with rules. If you understand the rules, you can maintain the system.
And if you ignore the rules, or if you rely on a parrot to tell you the rules, the fish die, or the code rots.
It makes that small change from IO args to IO feel almost philosophical. It's an act of aligning with the nature of the system.
And respecting its constraints. The system says, I will discard your value. The programmer says, fine, then I will give you nothing. It's a handshake.
Before we wrap up, I want to circle back to that idea of the discarded value. It's actually been stuck in my head.
In what way?
Well, the Haskell runtime is brutally efficient. It says, I don't need this, so I'm dumping it. And I/O is our way of admitting, okay, I won't give you anything to dump.
Right.
It makes me wonder about our own work, outside of coding.
You mean like in a corporate sense?
Yeah. How often do we, in our jobs or our studies, return IO args?
You mean preparing these huge, complex reports, detailed analytics that maybe nobody actually asked for?
Exactly. How often do we finish a project and hand over a 50-page slide deck or a complicated spreadsheet, and the runtime, whether that's our boss or our client, just silently discards it?
That is a painful question. Because we want our work to matter. We want the args to be used. But often, the system just wanted the side effect.
It just wanted the project done. It wanted the decision made. It didn't care about the artifacts we produced.
And just like in the code, doing that creates confusion. If I hand you a 50-page report, you feel this obligation to read it. You get cognitive load. You worry you missed something important.
But if I just say, it's done, we both move on.
So the lesson is, be more like I/O.
Be more like I/O. Be clear about the action, do the work, and then recognize when the transaction is finished. Don't burden the system with data it's not going to use.
Simplicity, clarity, and knowing when to just stop.
I think Aang would agree with that, whether he's coding or cleaning the filters on his fish tank.
I think so too. It's the plumber's way. Clean pipes, no leaks, and no waste.
Huge thanks to Aang at kianmeng.org for the notes. Keep tinkering, keep documenting, and please keep vetting the AI.
And thanks to everyone for listening.
We'll see you in the next deep dive.